I know, right? So. So are we getting somewhere? So so it's something about.
It's just the
Can you hear? Can you all hear him?
hello.
I suppose they can hear you.
Yeah.
Yes, they
Okay.
can hear you.
So for everyone who asked me about the Auto Gen 3 versus Test All and the discrepancies in bad tests when it comes to error messages, I know it's something that we still have to figure out, and I will still be looking at those manually. So if you see any like test failed in your bad tests because of a discrepancy in the error message, that's fine. And that can be said for any of the phases.
Okay,
Good.
cool. Right. So let's take a look at this grammar here. That's a little smaller than the one we had last time. So I think we can actually go through and do the whole 9 yards with this thing here. So let's give that a go. And I'm just going to skip that Q0 state. So we'll just start with S goes to dot A. And I have two options for A. We can do that or we can do that. So we need two epsilon transitions. We need A goes to dot B. And we need A goes to dot A. Right. There's not much we can do here except for a B. Oops, I should put in some epsilons here. And that will get us down to A goes to B dot. And over here, I don't have much of a choice either. We have to do an A in order to progress. And if we do that, we get to A dot A. So there we go. What else now? Let's see, over here we can do an A, and then we get to S goes to A dot. And down here, in order to do an A, well, we can do an epsilon up there, and an epsilon up there, and at some point we can do an A, come down here, and we have A goes to A dot. Now I'm just going to put some numbers on these. I'm going to call this one here 0, 1, 2, 3, 4, 5, and 6. And then I'm going to make an example string, and preferably one that's in this language. So see, what can we come up with? We can do AA. We don't want it too big. If I say AAB, that should be good, right? Now let's just sort of take a look at what we need to do in order to parse this. How am I going to have to flounder around in this? Well, at some point I'm going to have to end up here. Actually, at some point I'm going to have to end up here, because that says, right, we've gotten to the right hand side of the rule with the start symbol on the left. And in order to do that, I have to recognize that B. So at some point I'm going to have to come down this way. And once I've come down this way, I need to come back somewhere else so that I eventually can end back here and go over there. And it looks like this rule here has been applied twice. So it looks like we do one go around, another go around, epsilon up here, down here, back up, and over there. Now, how do I keep track of where I am? What we could do is we could say, listen, we're going to start in in state 0. And what do we do in state 0? Well, we can do one of three things. We can either say we're going to go down here or here, or we can say, hey, we've done an A. But we haven't done an A. We haven't done anything yet at all. So we got to pick one of these. Now, which one should I pick? Let's pick that one there. We're trying to do an S. Actually, so I'm going to say 0, and we're trying to do an S. Now we're going to go to 3 to try to do an A. Right. There's not much we can do here except we have to commit to eating an A off of the input. So we'll do that. And let's see, is this how we want to do this? Actually, hold on a second. I'm going to check something. I'm just making this up as we go along. That's why this is complicated. Actually, let me backtrack on this. Let's just say that we're in state 0 here. What do we do then? Well, then we go down. We'd have to go down this way because this is not going to work. There's no B at the beginning here, and there's only an A that we could eventually eat. So really, we're now in state 3, and then we can eat that A off the input, and we're now in state 5. What do I do in state 5? Well, I can either go up in state 2 or I can go to state 3 again. Well, it looks like we're going to have to go to state 3 again, and then we're going to have to go to state 5 again, and we eat that input. So now we've gone, should I try to do that in a different color? We'll do it in purple. We've gone down here, we've taken that A, we've gone around, we've taken another A. Oops, what did I do there? We'll come down here, eaten an A, come around, eaten an A. So now we're here. We're going to go over here and do a B. Come back here. 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 And end there. So we're now in state 5 and we're going to go to state 2. We're going to eat that B and go to state 4. Well, when we're in state 4, we can now go back to state 2 and say, I've done an A. But state 2 is not the one that deals with that A. That's state 5. So we can go back to state 5 and say, I've done an A. Oh, okay, good. What happens then when you've done an A there? Oh, I screwed up my picture. Let me redo that. Actually, let me do it with let me do it with this thing. So we started there, came down here, did a loop-de-loop, went up here, came back here, came up here, down here. Now we're actually going to have to go down here, come up here, go back to there, come back to here, do this one time, and now we can do that. That's a little confusing. But so we come back to state 5, having done an A. Well, now we can actually go to state 6. So from there, we can go to state 6. Right, so now we've done an A. So we can go back to state 5 and say we've done an A. Okay, so what? We can then go further back because we need to go 2 back to where the dot was there. Well, that's up here, so now we end back in state 3, and we've done an A. All right, so what? Well, now we got to go back to here, then go to 6, and come back to 3. We can go, we've done an A, we go to 6, come back, we've done an A. All right, so now we end up coming back to state 0, having done an A, and we can go to 1. Now this is awfully confusing. Why do we go down to state 6? Well, because, so let's see. Let me try to do a derivation. We say S goes to A, which goes to AA, which goes to AAA, which goes to AAB. That's got to be the derivation, right? So in order to get, so think about, we start here, we come down here, and we say, all right, what are we going to do now? Well, we're going to have to take this one here to read the first A. But now I need to do it one more time because there's more A's coming. So I'm going to have to go around here and come down here. Now I've read the second A. Now there are no more A's. I come over here. All right, in order to continue from here, I have to read the B. Now I've read the B, and I can come back to where I came from. Because in this state here now, we can say we've read an A, or we parsed an A, because that B from state 4 and state 2 completed that item in state 4, so we can now come back here and say we've done an A. Well, what happens in this state when I've done an A? I'm down here. What have I done now? Well, I've done an A in a state that is 2 steps away from where I am now. Well, that 2 step is 1, 2. So now I'm back here. I've done an A. Great. Here, back to a state where that was 2 steps away from me. 1, 2, and then the epsilon. And then I can go over here because I've done an A. And this, of course, is why it's virtually impossible to operate with this thing, because it's non-deterministic because we have all these epsilons. So I think we can say this is a mess to use. So let's turn this guy into a DFA and see if that actually makes anything easier. And I can guarantee you that it does. I will put it up here as a little guy just so we have a little reference. So let's see. We'll go back to a blue. We start with S goes to dot A. Then we can epsilon transition to here and to here, so we got to get those back in as well. So A goes to B and A goes to dot AA. So that's the epsilon closure in the NFH DFA of that first one. I'll call that I0. So what can I do now? I can leave this set here on an A, a B, or a capital A. All right, we'll do capital A up here because that one is easy, because it just gives me S goes to A dot. So that doesn't become anything else. And I think the B is probably easy as well, so we'll call that one I2 and do A goes to B dot. So there we go. Then the only other way out of this was on a little a, and that'll take us to I3. Let's see, that's when I left this region on an A, so I get this state, but I also get this one and that one. So I get A goes to A dot A, and then because of that and that, I come back and I get these again, but like we talked about last time, because the dot is there, then I got to include those two again. So now we have almost everything we need. We can go there on a B, there on an A, and then we just need capital A. I4, which is A goes to A dot 43. Actually, you know what? I'm going to call that one 2, and I'm going to call that one 1 because then it's the same as I have in the book. So there we go. Right. So let's try this again and see if it's any easier now. A, B. So we start here and we see an A. So we come down here. Then we see an A. So we come around here. Then we see a B. Now that B is, let me just redo this path so I don't. So now we're over here where B has been done, which means that the right hand side of that A is finished. So we can go back over here. We've now done an A. We can come down here. We go back 2 steps. 1 step was there, and then we follow this one back. Now we're back here. We've done another A. We'll dip down here. We got to go back to 1, and this is actually where we came from, was here. Now we've done an A. We can go over here, and then we're done. So this works much better because there are no confusions as to where to go. You just follow the arrows based on what the input is. So what we could see is when I came down here, and I did a loop-de-loop, and then I went over here. So the first time I actually did something that did a reduction was this B guy. So if I said that first time I did a reduction, or the first time I found a right hand side, so this is the first time I actually have a handle. So remember what we did. We had a stack. So, and we have some input, and the stack starts out empty, and the input is A, B, and $. So if we go back and just think about that rule that said, keep pushing things. So Benjamin says, so by putting multiple productions in one of those steps, we're saying we always execute all 3 of those rules listed. No, we're not, because if you look at this first guy here, right, it says, right, what can I do? Well, if I've done an A, and A here is a non-terminal, so in other words, that means if you have correctly parsed something that has A on the left-hand side, i.e., if you've gotten your dot all the way to the right, and you have a left-hand side that is an A, in other words, if that right-hand side has appeared on top of the stack and it is the handle, then you can now say, okay, I'll replace that by the A. So if you ever find yourself in state I0 with the information that you've actually done an A, then you can go over to I2. The only 2 other options is that you see an A on the input or you see a B on the input. If you see an A on the input, you go down this way and then you push that onto the stack, because we're now trying to see if we can build the handle on top of the stack. Remember, if there is a handle, it'll appear on top of the stack. So what we'll do is we'll go, right, we were in state 0. I'm going to incorporate that this time because that way I don't have to remember it. We were in state 0. Now we're going to push an A onto the stack, and we're going to be in state 3. Okay, what happens in state 3? Well, we have an A on the input, and there's not much you can do but go around there. Okay, so we get an A, and now we're in state 3 again. Now that A is gone. Now what? Well, there's a B on the input. Okay, a B from state 3 gets us over to state 1. All right, B1, and now there's nothing more on the input. Right, but now we're in state 1. The dot is all the way to the right. That means only one thing, namely that we have a handle on top of the stack. So that means on top of the stack should be this handle B. Well, it is. I can now replace that by an A. So if I just did, actually, let me write this out. That looked a little confusing. A, B. $, $0. Then we say $0 A3, and we have AB dollar there. And we say $0 A3 A3, and we have a B and a dollar there. And we say $0 A3 A3 B1, and we have a dollar there. So now we have a handle on the stack, and its A goes to B, so we can replace B by A. But if I replace B by A, so if I say $0 A3 A3 A, what state should I put there? Well, how did I end up here to begin with? Well, I came from over here. So I was here, took one step over here, put the B onto the stack, and said, ha, I have a handle. So now I can go back here and say, I've done an A. What do you do in state I3 when you've done an A? Well, you go to state 4. Okay, so it's reasonable that we have state 4 there. $. But what does that mean that I'm in state 4? That means that there's a handle on top of the stack. All right, so handle on the stack is A goes to A. Replace A by A. All right, fine. $0. Oh, let's just check first. A. Yes, indeed, there is a handle on top of the stack. A. How did I end up down here? Well, I must have taken 2 steps, so I need to find the state in which the dot was all the way to the left there. Where? Oops, I screwed up the 3 there, didn't I? I erased it a little bit too much. Where was that? Well, that must have been state 3, because I came down here on that A, and that little a was a trip around there, so that would have been there. All right, so we can say A3. We can actually also see that because of what's on the stack. That's why we built the stack this way. Oh, now we just got to move things a little bit. See if I can do that. Right, what do I got now? Well, I'm in state 3, so we're sitting around here. And I have, let's see, we've done an A, right? So we should actually end up in state 4, sorry. We came back to this state having done an A. What do you do on an A? You go to 4. All right, there we go. So now we still have a handle on the stack, exactly the same thing. So we get, well, we just get $0. Now the question is, where did I come from? Well, I came from state 0. How did I do that? Well, I went A. So now I'm in state 0 and I've done an A. We can go to state 2. A2. Now we're done. So I can do 2 things. If I have a terminal on an arrow, shift input onto the stack, and push the state. And if I have something like this, we should do that in a different color, shouldn't we? Do that in red. These mean a handle is on the stack, we can reduce. So if we actually look at what we did over here, and then we try to look at a derivation that represents this, then what was the first thing we did? Well, we at some point we went from AAB to a replacement of B by A. So AAB, the previous step then became AAA. Then what? Well, then that A and A was replaced by an A, so the previous step there was A. Then what? Well, then that A and A was replaced by an A, so the previous step here was an A, and that got us over here where we can actually do a replacement of that goes to S. So we can do that, and we really could have just said here $0 S, and then we're done. So this correctly created a reverse rightmost derivation, didn't it? Now, we still sort of haven't dealt with how to handle these. But if we think about what we did, I think it's most easily seen down here in the last one. What happened when I realized that I had a handle there? Well, I'm going to take that and their associated states off. Now this number that appears here is the state where I started this journey down there. So that's state 0. And I'm going back to that state having done an A, right? So I went from here to here. So dot there, 1, 2 hops. And those hops went from here to here to here. So now I'm back in state 0, which fits with that 0 there. And I've done an A. What should I do? Well, I should go to state 2. So in this situation, that and that determines new states after a reduction. So it sort of tells you where should you go to after you've done a reduction. So we were down here, and we said, all right, fine, we can do a reduction. We can replace the handle on top of the stack, little a, capital A, by A. Well, where should I go to then? Well, I should go back to where I came from, which was here, with the knowledge that I've done an A. So now you can go to state 2. So we call these non-terminals, they're going to be used to fill in a go-to table. And these other ones are going to be used to fill in an action table. So can I just try to actually do that? Because if I can tabularize this, see if I can actually do this without copying too much. We'll put that there. We'll clean it up a little bit. Actually, we can get rid of these things as well. That's good. So can I could make a nice table now that that sort of summarizes what I have here, can't I? So see how many things do we need? How many states do I have? 1, 2, 3, 0, 1, 2, 3, 4. And I have little a, little b, and $. Right, if I'm in state 0 and I see a little a, then shift that onto the input and go to state 3. If I see a b, shift that onto the input and go to state 1. If I see a $, there's nothing I can do because I can't leave state 0 on a dollar. If I'm in state 1 and I see, well, there are no arrows leaving there, so there's not much I can do. But I do have I have a complete item, don't I? So that's a complete item. So now we could say reduce by A goes to B. Reduce by A goes to B. Reduce by A goes to B. And then go back to where you came from and go to somewhere. But we'll have to incorporate the go to table in just a second. So this is my action table. There we go. Now, if you're in state 2, there's not much you can do there, but we know that if you ever get to state 2, you've now parsed an S. So shall we just say accept? I just want to say a quick thing about these oranges, that we are a little generous with these because this is sort of LR0 parsing. So I'm not really using the look ahead to anything but determine how to shift around. So I look at the look ahead when I decide if I go here or here. But by the time I come down to a reduction state, I'll just say either accept or reduce by whatever it is. What we will do at some point, we can say these entries will be limited later by follow sets. So instead of just, this is almost analogous to the stuff we did when we did recursive descent parsing, where we said if we have an epsilon transition, just fill up with epsilons in the end. This is almost the same. If we have a reduction, just fill up with the reduction. So all entries get reduced. But in reality, for this guy, I could get away with just doing reductions for anything that's in the follow set of A. And that's what we'll do when we get to SLR1 parsing. And then when we get to LR1 parsing, we'll say, right, we'll just do it on a subset of the follow set, namely the ones that could actually appear in this context. Right, in state 3, on a B, shift to 1, on an A, shift back to 3, and on a dollar, we get an arrow. And in state 4, it's reduced by A goes to AA, reduced by A goes to AA, the other way around. Then reduced by, oops, A goes to AA. So there we go. Which means that we still need to just deal with the go-to, so we'll just move that over there because then I can just sort of clunk it on here. This is going to be my go-to table. So if I'm in state 0, 1, 2, 3, or 4, and well, I only have A's, so we only need a column for A. And it's only if I'm in state 0 and I've done an A, I can go to 2, and if I'm in state 3 and I've done an A, I can go to 4. So that's what we got. right? So so can we do an algorithm now that uses this and does it in the right way? Well, remember we had that algorithm that said keep pushing things onto the stack until we have a handle. Well, what does it mean that I have a handle? Well, it means that if I run into one of these cells that has a reduction in, then I can do a reduction by replacing the top of the stack by the left hand side. Actually, the top of the stack is 2 times the length of the right hand side because I have symbols and states. So we could write an algorithm that looks something like this. S is my stack. It contains dollar and $0 just to signify the bottom of the stack, and we can also use that to figure out when we're done. All right. While true. So forever do. Well, let me grab the top of the stack. So I'm grabbing the top of the stack there. That's always a state. So we can then say if my action table in state S with whatever hold on a second, there's a mistake here, I think. Oh, let me redo this slightly. I want to redo this table here ever so slightly. I just want to compress it a little bit because if we looked at this thing here, then we can see that I'm always in one of 3 situations. I either have a whole arrow row that is reduction, or I have a whole row that is accept, or I have a whole row of shifts and arrows. So what if I did this instead? 0, 1, 2, 3, and 4. I'm going to call this column action. And then I'm going to extend my table a little bit here, and I'm going to have an A, a B, and a dollar. Well, it's a shift action in row 0. It's a reduce in row 1. It's an accept in row 2. It's a shift in row 3, and it's a reduction in row 4. Here I shift to 3, 1, and this is an error. Nothing there, nothing there, nothing there. Here I shift to 3, 1, error. Okay, so let me grab that, copy that, move that, put it there. I'll just delete that. So now let's do what we started on the other side, on the other page. So S is my stack, $0, while forever do the following. Little s is grab the top state of S, and if my action table, so this is my action table, in row S, so I'm looking in the action column, so that's that one. If that is equal to a shift, then, well, let's get the next thing on the input. Remember, it's zero look ahead. I'm not allowed to look ahead to determine what I want to do, but we knew we had to shift or error in some way, right? So now we can say push S comma E. So that pushes onto S this new input. All right. Now we can then check if action in row S for this input is error, then we can throw an error. Else we can push whatever's in the action table in state S and look ahead E. Now, if I wanted to, I could have taken this guy here and put down there with that. Maybe that would have been nicer. But since we're airing out anyways, it probably doesn't matter. So we'll do that. Else, well, if it's not a shift, then it could be a reduce. So let's check that. Can I just move that over here? So if action in my action column, so we're looking at this column, if that is reduced by A goes to alpha, then, well, we're going to pop S 2 times the length of the right-hand side times, because that's all the symbols and all the associated state. Then we're going to grab the top, because remember, when I did that here, before I put that A on, I actually had a quick peek at what was on top of the stack, because that told me, oh, you're here, you need to go back to here, and then you'll end up over there. So we need to peek at that thing there. So we'll just now say S is the top of the stack, and then we can push onto S A, because we're reducing by A goes to alpha. And then we can push onto S the entry of the go-to table at S comma A. So my go-to table is this one here. So I'm going to make a copy of that as well. Why did it end up down there? Put it there. And erase that. There we go. Else, it's accept, which in this case is just a return. Actually, that should be an end while, shouldn't it? So that's really all. That's really all there is to it. The question is just, how do I fill in this table? And once we have some look ahead, we don't need to clump things together in that action table in this rewritten way. We can actually use this, but we can use this one here, because you can see that if I just, what I did here, I clumped these actions out here so that I could just look up in here, knowing that state, I could figure out what to do without looking at the input. And once I figured out what to do, I could read the input, because that didn't count as looking ahead. And then I could figure out whether it was an error or it was a number to shift to. So that's what we did there. But if we had a look ahead of just one, then we could have said up here, if the action of S at whatever the look ahead is shift X, then push S comma E, push X. If it's error, then error. So we can just make this a little nicer by using the look ahead to figure out what column we're looking at anyways. This only works if the DFA is minimal. Well, so here's the thing. We're actually not going to do what, and I don't know if you noticed when I took this thing and I made it into this thing, I didn't really do it by looking at this thing here and then trying to figure out what these epsilon closures are. I computed these epsilon closures automatically in my head, and I'll show you how we can do that. Again, we can try. Let's actually try that. Or should we try to? We could try to do a parse with this again, but that's basically we've already done that, right? No, let's try to do. Let's see if we can replicate this thing without having that to look at. So we just have the grammar. So can we do the DFA without the NFA? And the grammar looked like S goes to A goes to little a, or B. So I know that in I0, I always start with the start symbol production dot all the way to the left. Now, in the NFA, we had epsilon transitions whenever I had a dot in front of a non-terminal. But if I have a dot in front of that A, I can just go into my grammar and say, all right, I need all the rules with A on the left, added as items with dots there and there. Well, that's easy enough. So I just get that and that. And now I don't get any more because I have dots in front of terminals, and there are no rules that have terminals on the left-hand side. So that's all I get there. This is actually the closure of the set that consists of S goes to dot A. Then on an A, I can go to I. Did I call that I2 or I1? I can't remember. I2. Which is defined, and I'll tell you what the definition for closure and this capital GoTo is. But you can probably fairly quickly figure out what is the GoTo of I0 on an A. Well, I grab everything with a dot in front of a capital A here, chunk it in here, and move the dot onto the other side. S goes to A dot. Can't have epsilon on the left-hand side of a context-free grammar rule, so that state doesn't get any bigger. Let's do a B. We get to I1, which is the go-to set of I0 on a B. So go in here, see, can I find anything with a dot in front of a B? This one. Put it in there, move the dot over. All right. A goes to B dot. Dot is already to the right, so there's no epsilon on the left-hand side of any rule. So that's it. Little a, we get to I3, which is the go-to of I0 on a little a, right? So find everything in here with a dot in front of a little a, that's that one. Move this into there with a dot on the other side. Easy enough. A goes to A dot A. But now I have a dot in front of a non-terminal. So now I have to add these two rules with dot all the way to the left. Okay, we can do that. Like that. And like that. Right. So now I can see that I have a dot in front of a B, and I have a dot in front of a little a, and I have a dot in front of a capital A. So there are going to be three ways out of here. But if I leave on a B, then I would go to a state where the dot was just there, but that's this one. Just be careful when you reuse states that they have to be exactly the same. What happens if I do an A? Well, an A will bring the dot over there, which gives me this guy, and when I do the closure operation, I get that. So I can go around there on an A, which also means that this set is actually also the go-to of I3 on an A, and this guy here is the go-to of I3 on a B. right? Last one, I can transition out of there to I4, right? That's the only one with a dot in front of an A. Put it in there with the dot on the other side. A goes to A dot. Yoink. So, see, I produced the DFA without even making the NFA, right? And this one is there a guarantee that this is going to be minimal?
Because reduce duplicate states.
Oh, right, yes. Well, of course, because we reuse states. Yes, good,
So
good point. Yeah. So what Ben says, when I'm here, I don't create a new state that. I don't create a new state that looks like this over here. And call it I5 or something like that. I reuse that one there. So by construction, I think this one will be minimal. But that was a good question. So I think we can agree that that's probably the case. Yeah, I'll buy that. Yeah. So what we just need to do next time, we just need to formalize what closure and go to does. And that's really fairly easy. We'll write it down next time, but I'll just say it again now. Here I started out with this guy and I apply the closure operation. What does that mean? Well, I say dot in front of an A. In the NFA, I would have taken off some epsilon transitions here, but here I just say, right, in order to parse an A, I got to do one of those rules. Well, with the dot all the way to the left, because I haven't done any of it yet, because I haven't done that A. Now I have a dot in front of an A. I can't have an A on the left-hand side, so there's no rule like that. Here I have a dot in front of a B. Again, no terminal on the left-hand side. So I don't get any more. But in general, I just keep adding things that have a dot in, that has a dot. If I have a dot in front of a non-terminal, then I go and find that non-terminal here and add its right-hand side. A common mistake that people do when they have to do this on an exam is they say, right, I'm going to take the entire grammar and I'm just going to fill it in there. That is not correct. You compute this first one as the closure of the start symbol with the dot all the way to the left. Sometimes it's everything. Sometimes it's not. If I had done the following, if I had put a capital C here and a C goes to something, there would have been no C's in here at all because I can't get over here to that C. And when I'm done computing the closure, I can now just look at this and say, well, a dot in front of an A, a little a, and a B, so there's got to be 3 ways out of here. Similarly, when I get the dot all the way to the right, then there are no ways out of there. At least not for that one. It could be that if you had other things in here, there could be. So when we have a dot in front of something, we can grab everything in here that has a dot in front of whatever that is, put them in this new state with the dot moved over, signifying that I've done an A. Similarly, if I have little a here, I grab everything in this state that has a dot in front of a little a, put it in here with a dot on the other side, and then compute the closure again, because now I have a dot in front of a capital A, and I gotta add these with dots there and there, and I end up with that. So that's as complicated as it gets when it comes to these things, and that's not super complicated at all, I think. So I just need to write down the definition of the closure and the go-to operation. So we need definition 411 and 412. And then we basically now already have done all the SLR one, and we'll try to do a bigger example next time as well. We'll actually do our grammar, our expression grammar, and see what happens. Any questions? I put phase 4 video up, and phase 4 is available. I'm not going to lecture on any of the type checking stuff yet because of the way the book does it is slightly different to the way it's done in the assignment. But the video is long. I think it's in. Actually, did I do this right? Let me just check real quick here, because I have a feeling I only put. Let me just. I just want to check. Name resolution was 2 hours and 23. Oh, type checking is only an hour and 40. Yeah, that's not too bad then. So go give that a look, see what you think. Any other questions? Nothing? They're very docile today. Maybe they're not alive anymore. Is the world still there? Or is it just...
It's pretty still. No, there's a couple of
It's been a long week. And we're only halfway through. It's only Tuesday. So I guess we'll have to have office hours tomorrow. No, it isn't. It's Thursday. Oh, you people. if
if it were Tuesday.
I have to clean all my windows on the weekend, so I'm not particularly looking forward to it. Yeah. Anyways, so what does Benjamin say? My only question I answered, which has to do with constructing the DFA, right? Okay. So no more of this constructing an NFA and turning it into a DFA. That's just kind of nonsense. Right. We are out of here then, unless there are any other questions. I'll stop recording. When is phase 4 due?